red, green, and blue. These are three primary colors that form the foundation of almost every modern display, from color reproduction to subpixel structure and image processing. But here at SID Display Week 2026, TCL CSOT is showing something rather unusual, an 85-inch LCD TV that adds a fourth subpixel, namely cyan, to create a native RGBC structure. And according to the display manufacturer, this allows the panel to achieve up to 131% of the BT 2020 color gamut. Now, that is an unusually ambitious claim because even today, most premium televisions, whether LCD, QD OLED or WOLED, still fall short of the full BT 2020 coverage. So the obvious question is, why add cyan? What problem is it trying to solve? And more importantly, does it actually improve picture quality in a meaningful way? Or is this simply another impressive-looking specification on paper? This sits within TCL CSOT's broader Apex display technology strategy, which is their framework for defining what they consider a premium, human-centric display experience. So in this video, we're going to take a closer look at what's actually new here, from this RGBC LCD panel to IJP OLED in automotive and hybrid work applications, and finally TCL CSOT's latest XR displays, and whether these innovations have genuine real-world relevance. Because ultimately, specifications only matter if they improve what you actually see and experience. Let's start with this 85-inch LCD panel. Traditionally, LCD displays use a standard RGB subpixel structure, red, green, and blue. Here, TCL CSOT has introduced cyan as a fourth primary color at the hardware level, creating a native RGBC 4-color pixel array. The goal is not simply more color, but specifically better color purity and wider color volume, particularly in blue and cyan regions, where conventional RGB structures can be more limited. By adding cyan, the panel can generate purer and more saturated blue light, expanding the color gamut beyond the traditional RGB triangle. That is how TCL CSOT arrives at a claim of up to 131% of the BT 2020 color space. Now, independent measurement would ultimately determine how this translates in real-world performance, because this is a hardware-level subpixel change rather than software manipulation. It also increases subpixel count and enables more refined rendering algorithms, which can improve high-frequency image detail and perceived resolution. So in theory, you get two key benefits, namely wider color reproduction and improved fine detail rendering. For home cinema applications, those are exactly the areas that tend to have the most visible impact, not simply brighter peak luminance numbers, but whether HDR content looks more natural, more saturated, and more convincing. This is part of TCL CSOT's Apex strategy, where Apex is built around four pillars. A stands for amazing display experience, P for protective of eye health, E for eco-friendly to build and use, and X for unlimited imaginative potential. The technical backbone behind this is something called Apex Pixel, which is essentially the engineering pathway driving pixel-level innovation across LCD, IJP OLED, FMM or fine metal mask OLED, and XR displays. To explain how that philosophy translates into real product innovation, let's hear from Mr. Ji-Fu Lee.
Apex is our guiding philosophy for innovation. It's about creating displays that are pleasant to use, healthy for the eyes, environmentally friendly, and future-ready. Instead of asking consumers to understand complicated technical specs, Apex helps them quickly recognize a high-quality screen.
The important point here is that Apex Pixel is not tied to a single display technology. Instead, it is about using different technologies where they make the most sense. And one of the best examples of this is in automotive displays. This is TCL CSOT's Intelligent Cockpit Display Suite 3.0. And the centerpiece is this 28-inch sliding and multi-curved IJP OLED display. If you have been following this channel, you will know that I've been paying close attention to IJP or inkjet-printed OLED because it has the potential to become one of the more important OLED manufacturing developments over the next few years. Unlike conventional OLED production, which relies heavily on vacuum thermal evaporation, IJP OLED uses inkjet printing to deposit the organic emissive materials. In theory, this can reduce material waste, simplify manufacturing complexity, improve luminous efficiency, and perhaps most importantly, enable much more flexible panel designs. That flexibility is exactly what you see here. This sliding control display can fully retract when parked to free up cabin space, then extend with a single touch during driving to provide a larger interactive surface for both driver and passenger users. It supports multiple display modes, half screen, 2/3 or full screen, as well as split screen functionality, allowing navigation, entertainment, and vehicle controls to run simultaneously. It feels less like a traditional fixed dashboard screen and more like an adaptive interface that changes depending on how the cabin is being used. Alongside this is the curved armrest display, which uses the same IJP OLED technology but applies it in a different ergonomic context. Instead of a flat control surface, the curved form improves both visual continuity and touch interaction, making the interface feels more integrated and intuitive. Of course, not everything here is OLED, and that is actually a good thing. Complementing these flexible OLED displays are advanced HUD systems using different technologies for different roles. For example, the micro LED AR HUD reaches up to 18,000 nits of visible brightness, projecting clear information directly onto the windshield while remaining visible even under strong ambient light. There is also a PHUD solution designed for lower power consumption, projecting speed, navigation, and warnings directly into the driver's line of sight for what TCL CSOT calls zero-eye movement interaction. This is the sensible engineering approach, matching the right display technology to the right use case, rather than forcing one solution to do everything. Beyond automotive, TCL CSOT is also applying IJP OLED to hybrid work scenarios. This is the world's first foldable and portable 28-inch IJP OLED monitor, using a trifold design with a folding radius of R1.8mm and an unfolded thickness of just 4.48mm. Fully open, it becomes a large ultra-wide display. Folded down, it compacts to a much more portable 16-inch form factor. It also supports multiple orientations, horizontal, vertical, and angle, thanks to a large water drop hinge design and integrated stand. Again, the interesting part is not simply that it folds. It's that IJP OLED makes this level of flexibility more practical both technically and commercially, and that is where the underlying panel technology matters. Now, another major focus for TCL CSOT this year is XR, and this is where Mr. Lee's own expertise comes in.
One of Apex core value is X, unlimited imaginative potential, which resonates strongly with XR. Guided by this philosophy, we are developing XR displays that feel nature in everyday's life, serving as a bridge between the physical and the virtual worlds.
The challenge with XR has always been the same: resolution, pixel density, brightness, and making the experience feel convincing enough that you forget that you are looking at a display. That is where these products become interesting. For example, this 2.24-inch real RGB OLED display achieves 1700 pixels per inch with a full RGB subpixel structure, not pentile, alongside a 1,000,000:1 contrast ratio and 120 Hz refresh rate. That matters because visible pixel structure is one of the fastest ways to break immersion in near-eye displays. If you can still see the panel, the illusion immediately weakens. Then there is this 0.28-inch single-chip full-color silicon-based micro-LED display, achieving an extraordinary PPI of more than 5,000. At that level, pixel visibility becomes effectively negligible for AR glasses and ultra-thin VR systems. Because micro-LED is self-emissive, it also offers the usual advantages of high brightness, strong contrast and wide color gamut, which are critical for convincing AR applications. There is also a 2200 ppi LCD XR display using LTPO-CoA Real RGB architecture, balancing high transmittance with lower power consumption. Again, the broader strategy is clear. LCD, OLED and micro-LED are all being developed in parallel, each chosen for the applications where they make the most technical sense. Finally, for mobile devices, TCL CSOT is showcasing its latest FMM OLED development called SuperPixel, focusing on three practical areas of higher clarity, smarter power efficiency and faster refresh rates. By increasing subpixel quantity and using a real RGB structure, TCL CSOT claims image sharpness comparable to higher resolution WQHD layouts while reducing power consumption by up to 25%. Because less bandwidth is required compared to conventional SPR approaches, refresh rates can also increase significantly, up to 40% higher, allowing for smoother gaming and motion performance. So, the real benefit here is not simply another panel specification, but sharper text, longer battery life, and better motion clarity, things users actually notice from day to day. And really, that is the common theme across TCL CSOT's entire SID Display Week 2026 booth. Whether it is an 85-inch RGBC LCD panel improving color performance for home cinema, IJP OLED enabling more flexible automotive interfaces and portable productivity, or ultra-high PPI XR displays making virtual worlds feel more believable, the goal is not innovation for the sake of innovation. It is pixel-level engineering solving actual user problems, because nobody watches a specification sheet. People watch films, people drive cars, people work, people play games. And the best display technology is usually the one you stop noticing, because the experience simply feels right. That, I think, is the strongest idea behind Apex. And honestly, if the 85-inch RGBC LCD panel performs in practice the way the engineering suggests on paper, that may be the most interesting part of the entire booth.